Dampness in buildings and diagnosis, module 12. Mould growth. There we are, picture of mould. Note the different colours of the moulds. Not all moulds are black by any stretch of the imagination. Mould grows beneath wallpaper. The mould is beneath the wallpaper, and note it is not on the surface of the paper. These situations where mould occurs as such are caused by dampness in the substrate. Both those cases were leaks externally. You can see, however, there is on the top one some staining of the wallpaper from the mould underneath. Typical mould pattern in a corner, mould on cold spots. Effects of missing insulation and mould, little spot in the middle there, well away from the edge. Insulation was missing in part in the centre. This is nothing to do with mould. It's a phenomenon known as pattern staining, often seen on ceilings, where we've got lightweight blocks and standard mortar between. An examination showed that you're around about half a degree cooler over the mortar beds. The surface temperature is about half a degree cooler. Tape lift shows that this is simply dust. Why it collects on the colder surface, I don't know. It is simply dust. The surfaces in the cases here were well above the dew point, so it's only dust that is collecting. There are over 100,000 species of mould. Less than 100 are commonly reported in the UK, most being Penicillium and Cladosporium. Stachybotrys atra or Shitarum, a so-called toxic mould, is uncommon, but it's not rare in the UK. They have the same requirement for growth and survival as rots. Other than a source of infection, they require air, oxygen, suitable temperature, nutrients and moisture. And in the case of mould, moisture is effectively the only controllable factor. Life cycle, same as any fungus basically. Start off at the top with a spore, lands on a suitable surface. If the conditions are right, it'll germinate, produces these very fine filaments, hyphae. They develop, and at some stage or another we will get a mycelium or fruiting body formed. Spores develop on that and they are released into the atmosphere. It's said that surface condensation is the most common cause of mould growth in the UK, but as we'll see, long-term maintenance of high humidities, that is in excess of 75% usually, without condensation, will also cause moulds to develop in stagnant areas, especially on moisture-sensitive materials such as leather, cloths, paper, cardboard. We can group these moulds, as we'll see in a minute, into primary, secondary and tertiary colonising moulds. What species of mould grows where depends on a number of factors, including humidity and the particular substrate. And this is the sequence of colonisation of susceptible substrates. Primary colonisers, 80% RH, don't need condensation, as indeed nor do you do for secondary colonisers and tertiary colonisers. The primary and secondary colonisers can initiate and develop without surface condensation. Mould on leather goods due to high humidity. I've monitored these. Condensation never occurred. The mould on the belt is present, but there's absolutely no mould on the clothing inside. No mould on that clothing. And it's likely that a good proportion of mould growth is a result of high humidity, not directly surface condensation on clothes, beddings or backs of furniture. Indeed, to get condensation on those in the middle of a room, you're going to need steam. Common moulds in buildings, there we are, another paper by Grant and Hunter, published in International Biodeterioration Bulletin. We can see there. Two of interest really are well, they're all quite of interest. You can see what the percentage is in all dwellings, and but in air samples, two of them show distinctly low levels, Fusarium and Stachybotrys. Fusarium and Stachybotrys, I believe, have very large spores. They're not very good at being airborne. And I also believe, I've been told, the Stachybotrys spores are also sticky, probably intended to be picked up by flies and so forth. Microbial contamination in buildings can vary greatly, and indeed it does this, or can do this, over extremely short periods of time. And it must also be fully appreciated that the presence of mould in a building does not constitute exposure. We now come to the toxic moulds. It is not effectively a scientific description, it's a media description. But in this media description there are 4 species of mould that are considered to be a toxic mould. The most common is Stachybotrys atra. A black-brown mould, it requires cellulose substrates. It's slimy and requires wet, damp substrates such as following flooding. It is a tertiary colonizer. It needs wet stuff. Penicillium is grouped. Some Penicillium are grouped in relation to toxic moulds. Aspergillus, usually Aspergillus fumigatus, which is farmer's lung. Also, Aspergillus fumigatus is present in large quantities in potting compost, greenhouses, home potting in properties, etc. And finally, Fusarium. So what are the detrimental health effects due to airborne moulds? Well, there are some proven health effects, almost all from agricultural or industrial exposure. Irritation of eyes, nose and throat, dermatitis, exacerbation of asthma, allergies probably the most common, and aspergillosis, that's farmer's lung. That is most common in immunosuppressed individuals. They are at most risk with reference to aspergillus or aspergillosis. Now there are a number of reported health effects. They're not proven. Fever, flu-like symptoms, fatigue, coughing up blood, nosebleeds, dizziness, headaches, diarrhea, vomiting and liver damage. So what does the scientific press have to say about it? Well, German Mould Guide, they reported that, let's just read the thing, hypersensitivity pneumonitis, which is generally produced by repeated exposure to very high concentration of spores. In simple terms, that's 1 million to 100 million per cubic meter, which cannot be expected to occur in residential properties indoors. And there are some interesting occupational exposures. Wood mills, 1 million to 100 million per cubic meter. These are spore levels. Silos, 1 million. British farms, 1 million spores per cubic meter. Walk through a field when they're haymaking and you can easily see this with the amount of material floating around in the atmosphere. Go down, potting sheds, here we go, 7,500 spores per cubic meter of Stachybotrys shatarum. Again, very, very common in potting compost. And simply by throwing a mouldy orange in a bin, there's a paper on this, it was quite interesting, that released over 200,000 spores per cubic meter into the air. And it's very important to appreciate that in the UK there are no standards for internal spore levels in domestic environments. I'll repeat that. It's important to note that in the UK there are no standards for internal spore levels in domestic environments. So more scientific stuff. Current evidence does not support the proposition that human health has been adversely affected by inhaled mycotoxins in the home, school or office environment. And lots of other quotes, the WHO, World Health Organization, and they simply reinforced the findings of the Institute of Medicine. That's their study group. That is, after reviewing the global and scientific and medical literature, the Institute of Medicine could not find sufficient evidence to support the argument that the normal presence of mould in residence and workplaces causes any adverse health effects. And indeed, a very similar statement from University Health Publishing and John Hopkins simply states, just because a particular mould can produce toxins, it doesn't mean it will. Even if the mould is producing toxins, a person must breathe in sufficient dose to be affected. It is highly unlikely that you could inhale enough mould in your home or office to receive a toxic dose. That's an atmospheric dose. And basically, they all come to the same conclusion, that there was an association between damp living conditions and some adverse health effects, but no one has ever conclusively shown it's due to mould. Most of the things are all associated with damp, and those factors are considered to be part of the etiological background. That's dust mites, bacteria, moulds, and so forth. And as such, the stress is placed on correcting the damp. So, on peer-reviewed literature, the fundamental problem is one of a long-term damp environment, and that gives rise to all kinds of other things. They are all associated with a damp environment. So whilst toxic moulds are not a total myth, they are certainly nowhere near as devastating as frequently reported in the media. And like many other factors, they're only likely to affect what I loosely call sensitive and immunosuppressed persons. By far the greatest proportion of the population will not be affected. Control of atmospheric moisture condensation and mould growth. You know all this basically, so it's just a little bit of a recap. There we are, typical ventilation rates in air exchanges per hour. Whether that's still valid, because this is from BS 5250 2002, it's probably even lower in recent years. So what do we need to do? We need to improve the ventilation to sweep out moisture-laden air and replace with drier air from outside. How do we do that? Well, ventilation, fans, manual humidistat, controlled and constant running. The idea is to remove the water at source. This is especially important in bathrooms and kitchens. Positive pressure systems, another way of ventilating, and I refer you to Part F of the building regulation for details of ventilation rates for the different methods. Positive pressure system in the roof, it's ducted out onto the landing, and indeed another system, positive pressure in a lounge, and that's ducted out to the hall. Positive pressure systems pull in from the outside external dry air. Remember, the air outside is inevitably drier, contains less atmospheric moisture than the air inside, because the principle of ventilation is to replace damp air inside with drier air from outside. So positive pressure then is pulling in external dry air. It's creating a pressure, a small tiny pressure indoors, and that will push out the damp air. Constant running fans and bathrooms, such as in bathrooms and kitchen, are actually producing a negative pressure. They're pulling out or pushing out the damp air, and the external air is coming in via vents. Both systems require some passive ventilation to allow the intake and exhale of air. We could try, if we have a subfloor condensation problem, we could try putting polythene water, which is designed to reduce the water vapour evaporating from the oversite. But also it's essential to maintain a good airflow through enough air bricks and make sure they're clear. And very important, reduce internal atmospheric moisture. If one looks at the data that's available, in reality, one would ideally keep the relative humidity in a domestic property in the winter below an average of around 55 to 60%, assuming 20 degrees centigrade. Remember, this is an average. You're going to get the data to go up and down. And this should be the same for any property, irrespective of size and occupation. If this cannot be achieved by temperature and or ventilation, then one should investigate why. However, the primary investigation should be the ventilation, assuming reasonable temperatures, and then have a look at the heating. So, back to the control of atmospheric moisture and condensation. Improve heating, make it constant, not intermittent. Raise the temperature to bring the environment out of the mould risk area. Also bear in mind that raising the temperature will raise the surface temperature of walls and therefore reduce the risk of mould. Effects of intermittent heating on walls. This could lead to short-term intermittent surface condensation, so beware. Reduce sources of moisture. Do not use bottled gas heaters or paraffin heaters. Apparently, large dogs give off as much water vapour, if not more water vapour, than a large human. Improve surface temperatures. We could use insulation. Improve the thermal properties of wall. Keep dry. For example, if you take a solid wall and it starts to get full of water from a long rainstorm, one of the factors that affects the thermal property is the capillarity, the air in the wall, in the capillaries. If that is replaced by water, then it reduces the thermal property of the wall. So one could, if you've got that typical problem, use an external silicone. That will reduce water penetration into the wall, and it has been shown to be effective in allowing the walls to warm up. Dehumidifiers are very popular and effective. But for moulds, we need to eliminate the moisture causing the problem and clean it down. It doesn't matter what mould is present, that is the fundamental cure for all moulds. And when we're looking at moulds, it is impossible to eliminate mould and mould spores in the indoor environment. And indeed, visible mould, although not a precise measure of exposure, is probably the clearest risk indicator for potential exposure. And clean-up, well, a visual and olfactory inspection is the most important step in identifying a possible contamination problem. Cleaning up is where there's no visible mould, no mouldy odours, and very important, you have fixed the moisture and water problem so that it will not recur. This is emphasised as fundamental in mould remediation. And all through the US Environmental Protection Agency documents is that it states the most practical approach is simply to eliminate all visible mould growth and smells from the environment. However, there might be some very rare cases where hidden mould may be, and I repeat, maybe or might be, a potential problem. For example, where there are known to be immunocompromised individuals. There's some really good advice from the WHO, the World Health Organization, which I think is very good. It says, I'm going to read it, management of moisture requires proper control of temperature and ventilation and so forth. Ventilation should be distributed effectively through space and stagnant air zones should be avoided. However, this I believe is very important. Building owners are responsible for providing a healthy workplace or living environment that is free of excess moisture and mould by ensuring proper building construction and maintenance. But what I like about this, it equally says the occupants are responsible for managing the use of water, heating and ventilation and appliances in a manner that does not lead to dampness and mould growth. I personally think that is an excellent balance of responsibility. But, and I've emphasised this, you can't emphasise it more, extremely important, if it becomes known that a sensitive individual might suffer harm from any such environmental conditions, then professional medical advice should be immediately sought by those individuals. Indeed, if anyone complains of ill health, then they should always seek medical advice from those qualified to give it. That's medically qualified. So you really need to get that advice. It is not for non-qualified people to give it. Anti-mould washes, pretty good. Bleach, suitable biocide. Anti-mould paints, they're also very useful where the problem is severe or you've got very difficult areas such as bathrooms. And that is an anti-mould paint after over 10 years of exposure compared with the non-painted equivalent. And finally, for interstitial condensation, most of the above, but especially improve ventilation, plus remove any external vapor resistant layers that allows water vapor to pass freely out through the wall, and install internal vapor control layers on the warm side. Indeed, this is to slow the water vapor movement into the wall. Dampness in Buildings and Diagnosis, end of Module 12. Please note, full notes of all modules may be obtained from the email address shown above.